हेलो स्टूडेंट्स, आज की इस वीडियो में हम डिस्कस करेंगे IUPAC नेमिंग ऑफ कोऑर्डिनेशन कंपाउंड्स. In this video, I'll take up three types of coordination compounds. One, in which the complex ion is positively charged. Another, in which the complex ion is having negative charge. And third, when the complex ion is neutral. Look at this example. If this coordination compound ionizes, it gives us CONH3 6 3 positive plus 3 Cl negative. Means the part of the compound which has been kept in this bracket, it is the complex compound, complex ion, and it is carrying positive charge. Similarly, in this, on ionization, it will give 4K positive plus FeCN6 4 negative. The complex ion is carrying negative charge. And in this nickel carbonyl, it is neutral complex, it will not ionize. Before I start the naming of compound, let us understand few important points. Let me take this example. The part of compound which is in this big bracket, that is known as complex ion, and outside it is the counter ion. It is written here to balance the charge of the complex ion. And the molecules or the ions which are attached to this metal atom is known as central metal atom. The molecules or ions which are forming coordinate bond with this metal atom, they are known as ligands. And the number of ligands attached to central metal atom, that is called coordination number. For naming of this coordination compound, the important point is that you should know the names of the ligands attached to central metal ion and as well as the charge carried by those ligands, whether this ligand is negatively charged, positively charged or neutral, and how much is the charge. Because unless we know the charge on the ligand, we cannot calculate the oxidation number of metal ion, and that is very important. While writing the name, we are to mention the oxidation state of metal ion. So the first thing which you are to learn before writing the names, that is the names of the ligands, charge carried on that ligand. Name and formula both should be known. You should know the formula of the ligand and its name as well as the charge carried by the ligand. So I have in every book, reference book, you will find a table where it is given the name, formula, charge of the ligand and how the ligand is named in case of coordination compound. Look here, I have made a simple table for you. See, this is the table in which here I have used the word unidentate ligands. Unidentate ligand means in the molecule or the ion there is one donor atom, which is there is only one atom which is forming coordination bond with the metal ion. So they are known as unidentate ligands. For example, these few ligands are carrying negative charge. Say first one I have written cyanide iron. The formula for this is Cn negative. And in this, the donor atom, it can be N as well as C, but at a time there will be one donor atom. Say here in Cn, donor atom is C and the charge carried by the ligand is -1. Similarly, halide ion, X negative, it can be fluorine, chlorine, bromine or iodine, right? So these ions, fluoride, chloride, bromide or iodide, each is carrying -1. So we have number of ligands which are having negative charge. Say this is sulfide, S2 negative, donor atom is sulfur and charge on the ligand is -2. These are the names of the ion. But while writing the name of these ions when they are being used as ligand in coordination compound, what do we do? The ligand in which the name is ending with E, in every ligand E is replaced by O. In case of negative ligand, the last letter E of the ligand is replaced by O while writing the name of ligands in the coordination compound. For example, cyanide, we will write it as cyanido. Chloride, we will write chlorido. This is hydroxide. We will write, earlier we used to call it hydroxo, but latest convention is we write it as hydroxido. E is replaced by O, so it becomes hydroxido. Amide, we write as amido. So you can just make your own table with the help of book, or you can just see here also. These are the ligands which are having, this is the name, formula, charge carried by, and the name of the ligand when it is used in the complex. Clear? You can take screenshot of this also. Then there are few more ligands which are carrying negative charge. Nitrate, we call it nitrato. Acetate, acetato. Then there are certain neutral ligands which are not carrying any charge. In that case, generally the ligands are given the same name as is the name of compound. For example, methylamine, CH3NH2. As a ligand, we also write it as methylamine. Then there is phosphine. We write as phosphine only. Pyridine, it is written as pyridine only. Triphenylphosphine, it is also written triphenylphosphine. But there are few important ligands which you have to always keep in mind. One is ammonia. When it is used as ligand, we write it as amine, A-M-M-I-N-E. Very important to note. Methylamine, we have A-M-I-N-E. But when ammonia is being used as a ligand, we write A-M-M-I-N-E. For water, we write aqua. These are neutral ligands, do not carry any charge. Charge present on ligand is 0. Carbon monoxide, it is called carbonyl. In this phosphine, pyridine, we write same as phosphine and pyridine. NO, nitric oxide, it is known as nitrosyl. When it is used as neutral ligand, we call it nitrosyl. Right? Then there are few examples I have taken of bidentate ligands. Bidentate ligands means they have two donor atoms. The two atoms can form coordination bond. Very simple example is this oxalate. Oxalic acid, you know, COOH, COOH. H has been removed, so it is COO negative, COO negative. Two oxygen atoms, they act as donor atom. They can form coordination bonds. So it is bidentate, means denticity, the number of atoms which are forming coordination bond is 2. So name written is oxalato. In the formula, sometimes it is also represented as OX. Symbol for this ligand is OX. Similarly, glycinate, written as glycinato. And these are carrying charge -1, oxalate is carrying 2. Then there is one important ligand, ethylene diamine, represented as EN, CH2NH2, CH2NH2, and it has two donor atoms, two nitrogen atoms. We name it as ethylene diamine, or nowadays we write it as new convention ethane 1,2-diamine. Very important ligand, used so many times. Then there are positive ligands. Positive ligands, these are monodentate and positive ligands. Their name ends with the IUM. This is hydrazinium, nitrosonium, nitronium. NO2, when it is carrying -1 charge, we call it nitro or nitrito N. But when it is used as NO2 positive, it is called nitronium. NO positive, nitrosonium. When it is used as neutral ligand, it is called nitrosyl. So what I mean to explain, what I want to explain here, that it is very important for you, make your own table, remember the names of ligands and the charge present on the ligands. Only then you will be able to write the names of coordination compounds. Clear? Then let us see few rules while naming the coordination compounds. The very important first rule that you all know, if we have any compound, say sodium NaCl, right? Formula is given NaCl. What do? We write sodium chloride. Sodium is positive and chlorine is negative. We always write the positive ion first, then negative ion. While writing the formula or while writing the name, always we write the name of positive ion, then negative ion. So in coordination compounds, again, while writing the names, we will start from left to right, like positive ion, then negative ion. First point is this. Then we see what is the charge present on the complex ion. If the complex ion is positive, how do we write the name of complex ion? We write the names of ligands in alphabetical order. First we start with the names of ligands in alphabetical order. Then metal atom to which ligands are attached. In bracket we write the oxidation state of that metal atom in Roman letters, and then the negative ion which is present outside the bracket. Clear? Ligands in alphabetical order, metal atom, name of metal atom, then its oxidation state in Roman letter in bracket, then negative ion present outside the bracket. This is the order for naming the compound. If there are 2 or 3 same ligands are present, we use di for 2, tri for 3, similarly tetra for 4, penta for 5, hexa for 6. But sometimes di or tri word is being used in the name of ligand. In that case, we don't use di or tri for 2 same ligands. We use bis for 2. Like there are 2 ethane diamine ligands. So di word is coming in the name of ligand. So we will write bis ethane diamine. Right? Tris for 3, tetra is for 4. You will follow more when we will do the examples. This is for positive ion. If the complex ion is negative, rule will remain the same. We will write ligands in alphabetical order, then metal, then oxidation state of metal, then the ion present. Here we are, complex ion is negative. Rule will be like, we will start from left to right. We will write positive ion first. Whether it is complex ion or simple metal atom, we have to write the name of positive ion first, then negative ion. So in this case, complex ion is negative. So naming of complex ion will be in the same manner as we have written for the positive ion. We will write the names of ligands in alphabetical order, then metal atom, then its oxidation state. But the difference is that while writing the name of metal atom, the name of metal atom will end with ATE. The name of metal atom that will end with ATE. Suppose it is cobalt, we'll write cobaltate, nickel, nickelate, chromium, chromate. Then silver, argentate, for silver we write argentate, copper, cuprate, tin, stannate, iron, ferrate. I have taken few, right? You can remember these also. So if the complex ion is positive or neutral, the name of metal will remain same. It will not change. But if complex ion is negative, the name of metal atom will be ending with ATE. So let us apply these rules while writing the names of few compounds. Let us start with, say this is the first compound, CONH3 6Cl3. If you just say this in this compound, it is CONH3 6 3 positive plus 3 Cl negative, means complex ion is positive and this is the counter ion. So name will start with the positive ion. First we will name this part, एंड वाइल राइटिंग दिस पार्ट हम सबसे पहले क्या लिखेंगे, लिगेंड्स के नेम, फिर मेटल एटम का. यू हैव टू फॉलो दिस. फर्स्ट लिगेंड्स इन अल्फाबेटिकल ऑर्डर, फिर मेटल, देन इट्स ऑक्सीडेशन स्टेट, देन नेगेटिव आयन. तो लिगेंड्स इज, व्हाट इज द लिगेंड प्रेजेंट हियर, दैट इज amine. How many? 6. For 6 means we write hexa. Clear? So name of ligand, we always write name in one word starting with the small letter. So it is hexa amine, AMMINE, amine, ammonia, we write it amine. Then name of the metal atom, cobalt, it will remain same. Then oxidation state of metal atom, then the ion present outside the bracket. For this we don't write di, tri, anything. We simply write the name because it is used to balance the charge. It is a counter ion, it is simply balancing the charge of the coordination compound. So we don't write here di or tri. So name will be hexa amine cobalt, oxidation state, then chloride. Now our next is how to find the oxidation state. I told you that for this you are to remember the charges present on the ligands. So ammonia, we have 0. We have to find the oxidation state of cobalt, so write it X. Ammonia charge is 0, plus 6 into 0 plus 3. Charge on chlorine is -1. Sum of the charges, total complex is neutral, so 0. So if you find the value of X here, that will be X minus 3 equals 0. So X is equal to 3. Means oxidation state of cobalt is 3, and it is written to be written in Roman letters like this. So this will be the name of compound. Let us come to this next compound. See the ligands. This is amine, this is chlorido, this is nitro or nitrito N, we can write. So it is the positive part, negative part. We have to name the positive part first, and we have to name the first ligands in alphabetical order. So it will be amine, A comes first. How many amine? 4. It will be tetra amine chlorido nitrito N, or nitro also we can write, nitro cobalt, oxidation state, and outside the bracket there is chloride. Clear? So this is the name. Now next step is to find the oxidation state. Very simple. X plus 4 into 0, chloride -1, nitrito -1, -1, total equal to 0. So X will come out to be 3, means oxidation state of cobalt is 3. Write in Roman letters. Okay. Now let us see this compound. In this is the potassium, and this is the complex ion. Potassium is positively charged, complex is negatively charged. So we have to write the positive ion first, whether it is complex ion or simple ion. So we start the name with potassium. For the ion present outside the bracket, no di or tri. Simple potassium. Right? Now we have to name the complex ion. Again ligands, पहले ligands के name लिखेंगे, फिर metal atom. These are 3, means tri. This ligand C2O4 is oxalate. We write it as oxalato. right? Oxalato. Then name of the metal. As now the complex ion is negative, so name of the metal will end with ATE. It will be cobaltate. Then oxidation state of metal. So let us find oxidation state of metal, that is 3 into +1 plus X plus 3 into -2 equal to 0. So it will be 3 plus X minus 6 equal to 0. X is equal to 3. So it will be 3. So only difference is that while writing the name of metal in the complex ion, if it is positive, name of metal will remain same, but if it is negative, the name of metal will end with ATE. Look at this. This is the complex ion carrying positive charge. Write the ligand first. This ligand is ethane 1,2-diamine. As in the ligand di word is coming, so we cannot use before it di or tri. Therefore, we have to use bis for 2, tris for 3. So it is 3 here. So name will start with tris. Ethane, name of ligand, ethane 1,2-diamine. It is a single M, diamine. As the complex is positive, so name of metal will same, cobalt. Here oxidation state of metal, that is how to find. Again it is X, and En is a neutral ligand, 3 into 0. So X plus 0 is equal to charge present, that is 3, means X is equal to 3. So oxidation state of cobalt is 3. Clear? And as the ion is not being balanced by any other ion, so we use the word here ion. Tris ethane 1,2-diamine cobalt 3 ion. So again I am reminding you that this you can write only if you know the names of the ligands and charges present on the ligands. Only then you will be able to follow. So I have explained few examples here. Hope you have followed and will do more and more practice of such examples. Thanks for watching. In my next video, we will discuss about the writing of formula when name is given. Till then, do the practice and try to learn how to write the names of coordination compounds.